Hello guys, so this is the last tutorial of this year, and obviously I'm gonna see you right after the Christmas holidays. So in this video I want to show you how you can paint on a static mesh using render targets. So you may think of games such as Splatoon or house renovation, or maybe paint simulator. I guess it's the right name of it. So I have kind of similar tutorial that I made a few years ago, but it has some issue that I have fixed in this version. Now I want to show you how it was then and how it is now. We're gonna start with the model breakdown. So you may see that this model has several material IDs, this, and this. And it also has non-uniform UV layout, so it's for some pieces out of the 0 and 1 bounds. So with the previous approach, once I start painting, I have some issues, and they are the following. So I start painting, you may see that everything works fine, right? But due to the so-called butterfly UVs, we also have the mirrored image of our paintbrush on the second part of our armor. Also, if I start painting, sorry, in the inside part of it, you may see that the size of the paintbrush is higher than we have here, right? It's due to the UV layout different scale. Also, as this UV layout is out of the bounds, I cannot paint on the second part of armor, just on this one. Now let me show you how it will look in the fixed version of this feature. So we're gonna change some elements, this and this. So now if I start painting here, you may see I have one size of a brush. We don't have mirrored brush on the second part of it. I can paint it right up here, and the brush size is uniform, just like this. So now let's start by building up the easiest parts. First of all, the main material of our model. The logic is kind of simple. We simply learn between the initial state, in my case it's the albedo color, and the debug color. You may also use here the, let's just say that you have the texture for your broken part. So in terms of the armor, you have the solid armor and you have the damaged armor. And then we need to learn between those states using the brush. It's the simple mask that we're gonna make with the help of render target. And the brush here is represented by the simple round shape, but it can also be used with some modifications, with some noise. It depends on the context. And this brush, we just need to have the red channel of it, and also make sure that the brush mask uses the UV channel of 1. It's the most important part here. So now let's modify our model. Here you may see that I have not only the native one, but the second one, which looks kind of different. So the main trick in this feature to make it work, that we need to use the light map UV that we can generate here in Unreal. So for this, in the details panel, you need to select the checkbox called generate light map UVs. Next, we can modify the size of it, so just like this. It's the new one. And we also need to define what UV channel we're gonna use as the source for generating the light map UVs. So here is the index of 0. It means it's our native UV layout. And the destination of light map index, so it's gonna be the UV1. So now let's make the brush with the help of which we're gonna reveal our second color, second damage state, wherever. So it's the simple material, and it's the additive blend mode, and the shade model is unlit. So additive needed so we can accumulate it by redrawing it on the render target. We need to do the following math. So from the texture coordinate, we need to subtract the custom attribute that we're gonna fill up with the help of our blueprint. So it's the vector 4, which is called UV, and we need to mask out two channels, red and green. Then we need to subtract 0.5, so then our UV map will start from not on the top left corner, but from the center of it. Next, we have the radial gradient exponential function, which can help us to get the round shape. And here we also define the radius of our brush. So with this one, we have the one brush, like this small. But if we change it, let's go with something like this. Now if we start painting, you see that the brush is much more bigger. So the next step is to enable the, how it is called, support UV from the heat result. So open up your project settings, and under the physics category, look for the support UV from heat results. So it only works for the static mesh, so it will help us to get the proper coordinate from the UV island on the specific material face, so we can know where our heat was. So yeah, select it and let's move on. So guys, now starts the more difficult part. So the idea is the following. On our level, we should instance a so-called World Painter Manager. It's a simple blueprint actor, which will track how many actors we have with ability to be painted on, and it will tell us, once we start painting, which actor is being triggered to be painted. So, with all this being said, first thing is to make the blueprint interface. To make one, you simply need to press right mouse button on your context browser, and under the blueprint, select blueprint interface. And that's it. And here we need to add two functions. The first one is called get painted render targets, and the output should be render target 2D type and the array type, not the single. The other function, store painted render targets. And here we have the input, which is texture render target 2D type, also the array. Now, let's say that you have actor that should be painted on. In the class settings, here on the right, you need to add the implemented interface, the mine called BPI actor utilities. So you made one, you press compile, now you will have on your left side the functions that we implement. Here we need to do the following. So we need first of all to make the variable called painted on the targets. So the type is texture on the target 2D, and it's also going to be array. And press, let's go like delete it. Press compile. Now select store painted on the target with the right mouse button. Select implement events. Once it's done, you simply need to pin everything. Now back to the World Paint Manager. So it's a simple actor which doesn't have much in here. So on the event begin play, we need to create dynamic material instance of our brush and store it as the reference, so we can use it later in our logic. Then we need to add a function called pass paint data. This function has the following inputs. So the incoming actor, it's a simple actor. Heat face index, it's a simple integer. And heat UV, it's the linear color. So once you've done this, now comes the logic. As I said earlier, we need to have the array so we can track how many actors that we're gonna paint on we have in our world, right? So it's gonna be array, and we need to create the variable, the global one, called painted actors. So it's the array of actors. Just before we start with the flow, let's also create some local variables. It's the way to organize your graph. So the actor render targets, texture render target 2D array, actor static mesh, it's the static mesh actor, static mesh component type, material slot integer, material interface, and material instance dynamic. And the last one is the temp RT, texture target 2D. So we need to check whether the incoming actor that we're gonna call this function on contains in the already tracked actors. If it's no, that we need to add it, and we use add unique. Then from the incoming actor, we check whether this actor has the static mesh component. So then we iterate with the for each loop, store it as the local variable, and from the static mesh component we get materials. We also need to iterate over it. So for each static component, we get each of these of his materials. We also store it as the local variables, and for each material constant, we create, using this as the reference, dynamic material instance. Then in the sequence, we create the render target, and here we define the size of it. The more, the bigger size is, the more precise and crispy result you will have. Don't forget that the format should be 8, so we can have only one channel that we use to reveal our damage state. So we have the reference for our render target. We use set texture parameter value in the material dynamic. Then we need to set material that we made with our new render target to the static mesh that we are operating with. Once we done it, we need to store our render target, this one, to the array of actor render targets. Then on the sequence, as we have the hit UV from the incoming function, this one, we're gonna set vector parameter to the brush material. And the brush material we have here because we created it on the event begin play. And right after we done everything here, we need to call a function called draw material to render target. And we draw our brush material to the render target here, just like this. So from the incoming actor, as we implemented the interface, we can call get painted render targets and store it to the actor render targets temporal variable. Then we need to iterate the same path that we have here for all of its static mesh component, and then we need to check with the help of function get material from collision face index. Using this index, we get the particular render target that we're gonna use to be painted on. Then we do the same thing as we did here. Now let's also make I guess it's the last piece of all this feature. It's the blueprint function library, where we're gonna define two functions. So to make the blueprint function library, also in the content browser, with the press of your right mouse button, select the blueprint and go to the blueprint function library. That's it. Here we need to make two functions. The first one is called get world painter manager. So simple, we can use this function, and this function is pure. The output is the reference to our newly created blueprint, world painter manager, that we talked about earlier in this tutorial. We get actor of this class and return it as the reference. And the second one is paint on mesh, the function that we're gonna call. And the reason why I use blueprint function library, because with the help of this approach, I can use this function every place that I want in my whole project. So here we need to make two local variables just for the graph to be clean, the logic is the following. We get player camera manager and we get camera location. So we're gonna somehow trace, and the trace using the camera manager is the best one because it will return you the current active camera. Next, for the same player camera manager, we get the camera rotation and we need to get the forward vector. Here we define the length of how long should our trace be. So it's 1000 units, so it's 10 meters. And we add it to the start location, so it's gonna be our end location. Then we use line trace by channel. By default, the channel gonna be visibility. Then from the out hit, we get the break hit result, and we check whether the blocking hit was true. Then we need from the World Painter Manager call a function that we implemented also earlier called pass paint data. And also from the out hit result, we get find collision UV and make sure that the UV channel is 1. It's also important. And from it we make linear color with the RGB and also store it as the hit UV here. Now, in the weapon component, it's the way how this template project is organized. We start shooting. I'm gonna call function called paint on mesh. So guys, with this being said, I'm really thankful for all of your support for the past year, and if you want to support me monetarily, you can follow up to the link under this video. I have Patreon, and you can buy a subscription, and you will also get this sample project. Leave your feedback, subscribe to my channel, share it to your friends, and see you soon, guys.